Alrighty. I do have one little point to point out that you are not allowed a calculator on these exams. Some professors may have not quite figured it out that there is a little calculator on ExamSoft, or if you're using a different exam platform. So I do encourage you to know your conversions and then try to work with the smallest number as possible, because you will not be allowed a calculator. If the professor would like you to round to the nearest 10th place, round to the 10th. So kind of getting in that habit of working with those numbers without a calculator. So the first part of tackling a question is try to not get overwhelmed by everything that's there, to really go through the question step by step and highlight or circle, or if you're having a paper exam, underline, whatever it is. You need to understand the different components of the question. Sometimes your professor might put a drug label there and you'll need to interpret that as well. So really looking for the bigger picture here before getting caught down in the minutia. You need to concentrate on being what is asked for. What is that final product? Does my professor want me to answer the question in milliliters? Am I looking for milliliters per hour, or am I looking for GTT per ml? That will be the drop rate formula. Or am I looking for kilograms and my professor has given me pounds? Really focusing on what unit is being asked for. When you're in these questions, sometimes you might have a number that's given to you in grams and one number might be in milligrams. As soon as you get to that question, try to maintain uniformity and convert everything into one standard unit. As soon as you see a pound, it should be converted into kilograms. As soon as you see a gram, that'll be written G or GM, it should be converted into milligrams, because that is the formula in order to get what you need. Most of these questions are, what do I have and what do I need? So writing down what you have, which would be your formulation of the drug, and what you need is the prescription. So really identifying the different components so that you could plug it back into a question. The step 6 is to consider the timing of administration of drugs when calculating total daily doses. So for example, if your professor is telling you that the following dosage is an appropriate Tylenol dosage, and now try to figure out the total daily dose if my patient were to get said dosage every 6 hours. So if I'm giving Tylenol every 6 hours, then I would be giving it 4 times a day, and I would then need to multiply my total drug quantity by 4 in order to get the total dosage for a 24-hour period. You might have some questions on diabetes related to insulin administration. If you guys have covered that so far, I encourage you to look it over. Registered Nurse RN on YouTube has great videos on that, knowing when you can give certain medications. So if you have a diabetic and you're giving a rapid acting insulin, when would you want to time food so you don't plummet their blood sugar? Feel free to click on any of the linked links in order to get more dosage questions. Again, Registered Nurse RN, she has a whole page and she's got a whole bunch of quizzes on her website, so feel free to check those out. Does anyone have any questions before we dive into some questions? There is a chat bar on the left-hand side, so feel free to type them in. Okay. I am going to ping you over first to just a chart with BenMath formulations. Feel free to screenshot or jot them down. And I will be sharing some of them periodically as we go. Yes, we will be covering pediatric calculations. Really, at the end of the day, they're all basically the same. A lot of the pediatric calculations focus on, is this a safe dosage for a child? Because my teeny tiny human is so fragile, so small, they can't really handle a little bit more of this or a little bit less of this. Okay, so screenshot this, jot them down. You need to know that 1 ounce is equal to 30 ml. 1 teaspoon is equal to 5 ml, which means that 1 tablespoon or 3 teaspoons is equal to 15 ml. 1 kilogram is equal to 2.2 pounds. Be careful when you're converting pounds or kilograms. The bigger number is always going to be pounds. The smaller number is always going to be kilograms. Think when you're traveling to a foreign or international country, your bag is like 24.5. No, you really don't have extra room. Your suitcase is still overweight, but it's in kilogram formation. In order to calculate an IV or milliliter rate, which is an hourly rate, it's basically saying I have a total volume. So I have a bag of IV fluid. I am hanging it on a pump, and I'm telling the pump how much of that bag to give per hour. So it's my total volume divided by the hours to be infused, and you end up with your milliliter per hour rate. So if you've ever been in a patient room and you see an IV bag hanging, let's say it's just regular old normal saline, for a little teeny tiny human, you're going to have a very small number. And that could, let's say, be 15 ml per hour. You have a really big adult who comes into an emergency room, and you got to fill their bladder up so you can do an ultrasound or CT scan them. You're hitting 999 because you want that fluid to go in really quickly. So you're doing the largest amount of fluid per hour. The IV drop rate, sometimes you don't have an IV pump, and so you're counting drops. A lot of nurses went through this during the pandemic. They didn't have IV pumps. They were counting those drops. And so it's your total volume, which is milliliters, over the minutes to be infused. So if your professor gives you a time in hours, you have to convert that to minutes. So if the professor writes 2 hours, that's 120 minutes times the drop factor. Well, Hannah, what is the drop factor? So the drop factor can either be 2 things. It could be a macro drip or it could be a micro drip. And they're the reverse of each other. And the way it works is that the micro drip has to do more drops per minute in order to get that same volume. So micro drip is always 60 GTT or drops per minute. The macro drip is either 10, 15, or 20. Your professor should designate in the question if they want macro drip, they should say which one it is. The safest bet is 10 GTT per minute if your professor hasn't said. But macro drip can be either 10, 15, or 20. So you're multiplying the total volume over the minutes to be infused times the drop factor, and you're going to end up with your number. Any questions so far? Okay. I'm going to share back that PowerPoint. We'll do 1 or 2 questions. We're going to review dimensional analysis, and then we're going to pull up IV rate calculations, reconstitutions. Those are the most frequently asked questions. And feel free to type on the chat. Okay, good question. So you should use those standard numbers. Micro drip will always be 60. Macro drip, I recommend using 10. Usually your professor will specify what it is, but if they haven't, I would stick with 10. So again, feel free to type messages in the chat. When I flip back and forth between Canvas, I'll read them and try to answer them. Alrighty, we will start with a small one. So we'll start with question 1. Feel free again to screenshot these questions. The answers are not written, but you're more than welcome to toggle with them, and we're going to work through some of them now. So we'll start with question 1. The doctor writes an order for Tylenol, 160 milligrams by mouth, as needed every 6 hours for pain for a child. The pharmacy dispenses you with 80 milligrams per milliliter. How many milliliters will you administer per dose? So the way I want you to approach this question is twofold, and we're going to point out something that is not listed in this question. The big one here is, well, this is a child. So even though it hasn't asked me if it's a safe dosage here, we need to figure out whether it's a safe dosage or not. A safe dosage of Tylenol is between 10 to 15 milligrams per kilogram. The hospital that I worked in, it was 12.5 milligrams per kilogram, within that safe range. So anytime you're giving a medication to a child, or really anyone, your license is on the line, you need to look up on what Lexicom, whatever service your hospital provides, and make sure that your medication is in an appropriate dosage. Make sure it's not too little, so that it's therapeutic, and make sure it's not too high, so it's toxic. So number 1, I need to make sure that this is a safe dosage for a child. 2, I need to compare what I have versus what I want. And what does that mean, what I have versus what I want? It means when I open up my charting, it says that my child, my patient, needs to get 160 milligrams. That is the concentration, milligrams by mouth. I open up the Omnicell and I'm pulling out these Tylenol little packets that I need to open, pour into a little medicine cup, and pull with a syringe. And it basically tells me that for every 1 milliliter, it has 80 milligrams. In 1 ml is dissolved 80 milligrams of Tylenol, mixed with all the cherry syrup and all the sugar that it is loaded with. So if my doctor has ordered 160 milligrams, I could just eyeball this question and be like, well, if the pharmacy is only giving me 1 ml per 80 milligrams, I could easily answer this question and say, well, it would be 2 ml. 1 ml per 80 milligrams equals 2 ml for 160. And the way you're going to do this is you're always going to set up your formulation in dimensional analysis, what I want times what I have. I'm going to put it on the screen on Canvas. Once I click, you'll be able to see it, okay? So what I want is 160 milligrams. What I have is 1 milliliter for every 80 milligrams. And this is the way you're going to set up all of your calculations when you're doing dimensional analysis. What I want times what I have. Now, the fun thing about this is that you get to cancel out things. So I am going to take my little raggedy pencil here and I go like this. And my milligrams cancel. So I'm looking for, in the end, milliliters. I'm looking for a fluid content. How much fluid am I dispensing to my patient? And if I go across, I end with 160 over 80 in milliliters, which equals 2. Does anyone have any questions on how I got that answer? Okay, if we go back to the question just to make sure that we answered it appropriately. We will see here that I was supposed to come up with milliliters per dose. So per dose, I am giving 2 ml per dose. If it says every 6 hours for pain for a child, that means that within a 24-hour period, I am giving it 4 times. 6 times 4 is 24. So my total dosage that I am giving for Tylenol is 160 milligrams times 4, within a 24-hour period, my child will have gotten 640 milligrams of Tylenol. Each dose, 160. Any questions before we flip to a different kind of question? Sure. I will try to figure out a way to do that. I might be able to like screenshot it. I don't know if I can like add a document into to the chat. Okay, so you'll see here on the PowerPoint presentation that there are 3 methods that you can use to solve math problems. My brain works on dimensional analysis. If you're finding that the other ways work for you, feel free to keep on practicing that way. But for the purposes of tonight's presentation, we'll be focusing on dimensional analysis. Just some things to remind you. Know your abbreviations. Know that mg is milligrams, gm is grams. Just really getting into the habit of recognizing different things, knowing that PO is by mouth, IV is an IV medication. You might be asked on your math exams to calculate input and output. So it might give you a question and it'll be like, patient had 130 ml. Patient had 120 ml of soup. Patient had 45 ml or ounces or whatever it is of applesauce. Patient had a total urinary output within a 24-hour period of 2000 ml. And it'll just kind of have you be able to balance is what the patient taking in matching what they're outputting. Military time. Feel free to switch your phones, your Apple Watches, your Fitbits, all of the above to military time. It ends up being so much easier because you can calculate a lot faster medications and then they're due in like a certain amount of hours. So let's say you have a drug that you gave at 12 noon, so that's still 12, and then I'm giving it in 6 hours, so that's 1800, which is 6 o'clock. And so it's just a little easier. Okay, we're gonna pick one of these and we will do number 3 because it's the most complicated in terms of if you can figure out the way the metric system works. Same concept for all of them, but we'll do one question on basic conversion. Feel free to start doing this one on your own, see if you can get a head start, and then we'll flip it back up on the board. While you're doing that, feel free to type in the chat if you know what microgram is in exponential or exponent form. So again, that's how many micrograms does 2.5 grams make? Think about this question. What do I have and what do I want? Yes, the screen has changed. I'm flipping it back as we're getting ready to go over the question for the purposes of time, but just to remind you all, it is the number that it gave you is 2.5 grams, and it wants to know how many micrograms that makes, which means your final number needs to be in micrograms. And the question that I wanted you to think about was in exponent factor, or what is a microgram? Alrighty, so this is our metric system little line where we will go up the line and down the line. We will start here in the middle with one, sorry, I don't have a touchscreen computer. So it's the little writing on the little pad there. So gram is right in the middle. We're going to call that basically 0 or 1. We'll make it 1. So 1 gram. If I go to the right of 1 gram, my number is going to get bigger. If I go to the left of 1 gram, my number is going to get smaller. So a macrogram or something like that, that is to the right and that's bigger. Micrograms, milligrams, those are all to the left of the line. That number is smaller. We are going to need to add zeros. 1 microgram is 10 to the negative 6. So think 6 zeros. 1 milligram relative to a gram is 10 to the negative 3rd. So that's 1,000. So for every 1 gram, that's 1,000 milligrams. So milligrams are going to be right here. Micrograms are going to be further to the left of that. And our little UG is 10 to the negative 6. 1 million there. And everything else is greater, but irrelevant to this part of the question. So when I answer this, I can either know in my brain, under no stress, that microgram is 10 to the negative 6. But if I come to the exam and I'm like, oh gosh, I really don't know, but I know that it's 1,000 times smaller than a milligram, this is how I would answer this question via dimensional analysis. And we would go as such. And again, you will not see what I am typing until I click out of the text box. To answer the question, this is being recorded. You'll be able to access it via the Office of Academic Success under concluded conferences. The first little part got cut off, but should be okay. So what I want, or my prescription here, is 2.5 grams times, again, we're doing this the slow way, and you'll see this when I finish typing this all out. I apologize that you cannot see it. And this will be your answer. Well, the answer is not there, but this is how you would set it up. And here, everything is crossing out in perfect dimensional analysis. In my brain, I'm saying here, what I want is 2.5 grams. And I know that for every 1 gram, I have 1,000 milligrams. Great. Now, if I were to multiply that out, my number is getting smaller. So I would do 2.5 times 1,000. And I get, okay, I have 2,500. I have 2,500 milligrams. And I know that for every 1 milligram, there's 1,000 micrograms. So I'm going to multiply my 2,500 times 1,000. And I am left with a very big number in microgram form. Now, if I think about it relative, it makes perfect sense because there was 2.5 grams, and I know that a microgram is 10 to the negative 6. So I basically moved my decimal point over because we're going in the metric system here. And this is my answer. You could have done that just by knowing that microgram is 10 to the negative 6, or you could have done it via dimensional analysis and did the step straight through. Any questions before we move on? Alrighty. We would follow the same process By again doing what my order is times what I need. So if my order is 500 milligrams, I'm going to write out 500 milligrams times. Again, everything needs to line up. So 1 milliliter over 100 milligrams. And if I were to multiply that out, it would be 5. And if you think about it, 100 milligrams equals 1 ml. So 500 milligrams is 5 ml. Same process here. This question is actually written incorrectly. There are no units in the second part of it, but it should be 1 milliliter for 1,000 milligrams, and you would follow that same process. This is just a little bit of information regarding insulin, about knowing that which insulin that you can mix, clear before cloudy, doing all those things, and just making sure that your insulin is formulated appropriately. In most hospitals, I have not seen it done differently elsewhere. We do not round up, we actually round down, especially in pediatric hospitals. We always go to the nearest half unit, which means 0.5 or a whole number. So let's say my patient is written for 2.7 units of insulin. I would be giving them 2.5 units of insulin, and I would not round up to 3 units of insulin. It's a 2RN check drug, and I would always err on the side of caution. We talked about macro drip and micro drip, and we'll go into a question for that. So let's do a drip rate question. Again, our formula is my total volume over the minutes to be infused. And Jane was really nice here, and she wrote 120 minutes, and she didn't write 2 hours, using a macro drip factor. So here, they're telling us that the drop factor for the macro drip is 10, because remember, it could be 10, 15, or 20. So see if you can start this question on your own. Again, the formula is total volume over minutes to be infused times the drop factor. And let's see what you get. I see some answers, but do not forget your units of measurement. If you were to write your answer without a unit of measurement on your exam, you would be marked incorrectly. Perfect. The answer is 40 drops per minute. We will go over on how to solve for that just shortly. Alrighty, we are doing dimensional analysis. Things are still going to cross out. Our total volume was 480 ml. Divided by my minutes to be infused. Here it's 120 minutes. Now I'm going to multiply the whole thing by the drop factor, which was 10 GTT per ml. And so when I cross multiply and just do it across, what crosses out? My milliliters cross out, and I am left with a GTT, and I am left with a minute. And so if you do that math across, you do 480 divided by 120 equals 4. 4 times 10 is 40. Your answer is 40 GTT drops per minute. Any questions on how we solve that? Alrighty. So that is technically written out cross-dimensionally, and that would solve it that way. Can everyone see the problem shared? It should be pretty big on your end. Okay. Let's read the question together. Patient is to receive Ceftaz, so that's the brand name. Ceftaz 500 milligrams Q12 in 100 cc's or milliliters of D5W by IV Piggyback. The pharmacy sent a vial of dry powder labeled Ceftaz 1 gram with instructions to reconstitute the powder with 10 ml of sterile water that will result in 10 ml of drug solution. And the question would like us to solve for how many milliliters of solution are we adding to my piggyback bag? And if the drop rate of the IV tubing is 15 GTT per ml, so macro drip, how fast will you set the drip rate in GTT per minute to infuse the solution over 1 hour? So if you're feeling lost, that's because a lot of information just got thrown at you. And the way to approach these questions is to take it one step at a time, convert things that aren't in the right form, and talk it through to yourself. And if you're in person and wearing a mask, it's perfect. You can have a private conversation going through this and nobody will know. So my order is 500 milligrams. What I'm going to do once I get all that medicine that's reconstituted, if pharmacy hasn't done it already, I'm going to take my 500 milligrams in whatever ml quantity it's going to come to, and I'm going to inject it into a bag of D5W, because it would be really not nice to my patient if I just took a syringe of antibiotics, attached it to their IV, and said, here we go, have a nice day. You want it going nice and slow. And so we're diluting it in D5W. The pharmacy sent me my medication, 1 gram. So really, that's 1,000 milligrams. So the pharmacy sent me 1,000 milligrams of the medicine with instructions and said, hey, take this 1,000 milligrams and you need to dilute it in water, sterile water, and to result in a total drug reconstitution quantity of 10 ml. So if I'm going to do this out by dimensional analysis, I'm going to say, what I want is 500 milligrams. What I have is 10 ml per 1,000 milligrams. So before I write that out, that comes to 5 milliliters. So basically, the pharmacy gave you too much. They gave you a double dose. Your patient is only written for 500 milligrams. So how many milliliters of the solution will you add to the piggyback bag? After we talk this through, I'll write it out, but you're giving them half. You're giving them 5. Now, if the drop rate of the IV tubing is 15 GTT per ml, how fast am I going to set my pump for? Well, what's my total volume? Well, I had to add that 5 milliliters to my 100 ml of D5W. So my total volume that I have hanging in my bag is not 100 milliliters, it's 105 milliliters. And so my total volume in my GTT per minute formula is going to be 105. So I'm going to pull up my screen right here. We'll hit to a new slide and we will solve this together. So what my dosage is 500 milligrams. We will cover where we pulled all the numbers from, no worries. What I had, and again, I had to reconstitute it. So I got the powder. I call it like, it's like doing drugs in the hospital. You're sitting there in the med room and you're reconstituting things. It's just one big party. So the pharmacy said, here's the powder. Make sure to put 10 ml. If any of you have worked in a vaccine clinic, you'll notice that the COVID-19 Pfizer vaccine comes in a powder form, and it needs to be reconstituted. Or maybe it's not Pfizer, or it's J&J. It's one of them. One of them needs to be reconstituted. And so you'll get it in the powder form, and then you have to put the fluid in. So here's my 10 ml. And I know that that's going to be 1,000 milligrams of ceftaz. So if I multiply this across, I want 500 milligrams of ceftaz, but what I have is a 1,000 milligrams of ceftaz diluted in 10 ml of fluid. So if I go across here and I dimensional analysis it out, you end up with 5 ml. And you can do the math while going across. Any questions before we move on to the next part? Okay. What I want, my patient has been written for by the doctor for 500 milligrams of an antibiotic. The pharmacy sent me 1,000 milligrams of this antibiotic, but they sent it to me in a powder form. So it's no use to me to be just giving my patient powdered antibiotic. They're telling me, the pharmacy, that I need to take some sterile water or sterile saline, whatever it is, whatever you have on in your med cabinet, and you need to inject 10 ml of sterile water into your vial of antibiotic. And then you need to gently invert it or turn it the 10 times, whatever you need to do. So now pharmacy sent me 1,000 milligrams reconstituted in 10 milliliters of sterile water. But my order is only for 500 milligrams. So my patient is only getting half of that vial. So they're getting 5 ml. So if 10 ml has 1,000 milligrams, 5 ml should have 500 milligrams. So now the question wants me to solve for the drip rate. So what is IV piggyback? IV piggyback basically means that I'm hanging my antibiotics, and I also have other things hanging at the same time, and it's piggybacking off of it. So I might have normal saline or lactated ringers just chilling and infusing at 50 milliliters per hour, and I got my little piggyback bag of D5W with my antibiotic going in at the same time. It's piggybacking off of my original IV tubing set. So if my D5W bag has 100 milliliters in it, I need to take my 5 ml of antibiotic, inject it into this bag. So I end up with a total volume of 105 milliliters. So let's draw it out. My total volume is 105 ml. I am infusing it over 1 hour. So that's 60 minutes. The ratio always asks for minutes. And it tells me what the drip rate is. And the drip rate is a macro drip. It's 15 GTT per ml. And drip rate formulas will always come out in GTT per minute. So if I dimensional analysis this, my milliliters cross out, and I'm left with GTT per minute. So let's all do this together. 105 over 60 times 15 equals 26.25 per drops per minute. But you can't have 0.25 of a drop. So in this case, I would round down and I would say that it is 26 drops per minute. Any questions? Sure. So my 5 ml that I got in the top portion of the question is the antibiotic. But I can't just give the antibiotic straight to the patient. I need to dilute it yet again in a fluid. And in that question, the fluid was D5W. It could have been something else. It could have been lactated ringers, or it could have been whatever it is. So I'm adding my very small quantity of medicine to the big bag, or here, not so big because it's only 100 cc's or 100 milliliters, to the 100 milliliter bag. And I end up with 100 plus 5 equals 105. So ceftaz plus D5W here is your total volume. Would I ever round up for GTT per minute? Yeah. If it were, let's say, 26.8 Drops, I'd round up to it is. And again, it would also depend on the drug. Like if it were insulin, but insulin would always go on a pump, especially in pediatric hospital. We don't do drops. But it would really depend on the medication. If it's like an antibiotic, I would very comfortably round up, unless it were a major in crisis hemonker. Then I would be like, I'll round down and slow is better. Any questions before we move on? We're going to do a very similar question here. And I want to see if you guys feel comfortable. Yeah, I would go to 27 drops because again, you're above 5. The answer, so let's go back. Good point. Let us share the screen one more time. So how many milliliters of solution am I adding to the piggyback bag? So the student originally wrote 10. That answer is wrong. The answer is 5. And if the drop rate of the IV tubing is blank, 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 how fast am I setting it to infuse over 1 hour? We said 26 drops per minute. Okay, stick with what your professor said. One of your fellow classmates has said that your adult health 2 professor said for drops to round down. So really stick with what your professor says. That is the holy word here. Okay, so the NP orders another antibiotic, and we want Clinda, 300 milligrams IV. The pharmacy has sent me 500 milligrams of powder clindamycin. So already I'm thinking here, well, the pharmacy sent me more than I need. So, which means that my total volume is going to be less than the number that is listed in this question. So the label reads and says, here's your powder. You need to put 5 milliliters of normal saline in it. Take a stab at it. See if you can answer how many milliliters you should administer. I should probably do this question also. And again, think of what is my order and what do I have? Awesome. I see 2 students have put the correct answer in the chat bar along with a correct unit. The answer is 3 ml. Let's do this one together. My order is 300 milligrams. What I have is 5 ml for 500 milligrams. If you were to multiply this cross things out, you would end up with 3 milliliters. Now, if I were to tell you, well, I want you to dilute my 3 ml of clindamycin in a 500 ml bag of LR. So again, I want you to dilute a 500 milliliter bag of lactated ringers with 5 ml of Ceftaz and I want this to go over 6 hours, what is your IV hourly rate? Again, 5 milliliters of ceftaz diluted into 500 milliliters of lactated ringers going over 6 hours. What is your milliliter per hour or hourly IV rate? Awesome. The answer is 84.16. You can't have decimal points on IV pumps. Your answer would round down to 84 milliliters per hour. The way I got to that was I said, okay, I have a 500 milliliter bag of lactated ringers, or half a liter, and I'm going to add my clindamycin. So that comes to a total of 505 milliliters going over 6 hours. So that's 505 divided by 6. Think about if you, let's say, you are dog sitting and the dog owner has left you a certain amount of treats and you want to divide them perfectly over said hours. You would divide the total amount of treats per how many hours you are dog sitting. Any questions before we move on? Sure. So I have 500 milliliters of LR, lactated ringers, plus 5 ml of clindamycin, which gives me a total volume of 505 milliliters. I told you that I want I want this going over 6 hours. So the formula for IV per milliliter or IV milliliter per hour rate formula is always going to be the total volume over hours to be infused. So it's 505 ml over 6 hours. And if I do the math, that comes to 84 milliliters per hour. This is the same question. I just added another step to take it a step further. Okay. Again, to answer this question, you would do your total volume, 300 milliliters, over 60 minutes, times 60 GTT per ml, and you would get your answer. Again, what would be the rate of infusion here? My total volume over the quantity of hours to be infused. So 500 over 2 would be 250 milliliters per hour. Some of these are logic. Some of the questions might require you to kind of give it a little more thought to it. So here we have 400 milligrams of ampicillin. That's my order. And they want me to dilute my ampicillin in 250 ml and to have it go over 60 minutes. And we would follow the same calculation, okay? Because here the quantity is so small, it's 0.4 ml, the question here has determined that that volume is not, and it hasn't made it 251. It's rounded down here. So that total volume would stay the same. Things to remember when going through IV questions is that your professor might want you to determine total quantities and then divide by the appropriate amount of hours. So if it's every 6 hours, you would divide by 4. And then if it would be every 8 hours, you would be giving that 3 times a day. Here is a very exciting question. See if you can have a go at it, and let's see what you come up with. After this one, we will save the last 5 minutes for questions. We will be transitioning over until 9 p.m. for what is called open or drop-in tutoring through the Office of Academic Success. It will be another Canvas invitation. You're more than welcome to join and ask as many questions as you want. Perfect. Again, this one's like more of a logic one. So the way we got to 10 milliliters per hour is, again, if you have 100 milligrams in 100 ml and it's 10 milligrams per hour, you want to think about it that way. What's the difference between 10 milligrams and 100 milligrams? The difference is 10. And so it would be 10 milliliters per hour. And that would take a total of 10 hours. Does anyone have any questions? I'm unable to attach things, so I'll slowly ping up the other things. You're more than welcome to take screenshots of the pictures. And I will try to zoom in on this one. I know you guys mentioned you couldn't really see it before. Regarding the last question that we did, again, what you want is 100 milligrams of Lasix. That's your order. And you know that it is diluted in 100 milliliters of D5W. So if my rate is for every 1 hour, and we'll cross this out here, we'll think about it this way. If you're doing 10 milligrams per 1 hour, that means that it's going to take a total of 10 hours in order to get that full volume there. So it's 10 ml per hour. Feel free to screenshot these as well. I will ping you up the question after. As a reminder, this session, you will be able to re-listen to it. Feel free to check out all the resources available on the Canvas page from the Office of Academic Success. And if you have additional questions, feel free to wait for that Canvas question. I currently do not have the answers to the questions. I'm more than happy to go through them with you at drop-in hours, or you can run your answers by me there. And that is the question, if anyone wanted to screenshot. And the rationale is here. Again, this PowerPoint is available at the Office of Academic Success Canvas page. Let me know if you guys are able to see that bottom of question 10 now. Okay, awesome. I will be closing out the session. If you feel like you have more questions, feel free to head on over to the next Canvas invitation.